Okay, so we're going to be talking about the cerebral dominance theory of stuttering. So first, we wanted to start with just a brief anatomy and physiology review of the brain, just so we can visualize the areas we're going to be talking about. So first, in purple, you can see Broca's area, and that area is responsible for speech production. Then in yellow, we have Wernicke's area, and that area is responsible for speech comprehension. And as you can see, both these areas are on the left hemisphere of the brain. The purple area is in the frontal lobe, and the yellow area is in the temporal lobe. Then here, this image shows both hemispheres of the brain, just more easy to visualize how they're divided. Blue is the left hemisphere, and the pinkish purple is the right hemisphere. And so the human brain is divided into two hemispheres, left and right. The left hemisphere is responsible for speech comprehension and production. And then there is contralateral motor control. So that basically just means that the left side of the brain would control the right side of the body and vice versa. Okay, so for the definition of our theory, cerebral dominance in stuttering theorizes that clients who stutter are cerebrally dominant on the right side of their brain and weak on the left side of the brain. This would indicate that the client's stuttering is contributable to poor language motor planning, insufficient speech organization, and impaired management of spoken language. So to explain our theory further, as early as the 1920s, researchers were exploring the concept of a dichotomy between the two hemispheres of the brain. These researchers proposed the concept of right and left ear advantage within clients. This means that the client's response time to auditory stimuli is quicker in the proposed dominant ear. The findings regarding ear dominance relate to hemispheric dominance in speech and language. So basically, the cerebral dominance theory proposed that clients who stutter are cerebrally dominant on the right hemisphere of their brain, which means that the functions controlled on the left hemisphere of the brain are weaker in those who stutter than in individuals who do not stutter. This weakness of the left hemisphere leads to poor motor planning and execution of expressive speech. Stuttered speech is then the result of this left hemispheric weakness.
And then I'm going to go ahead and explain this clinical scenario. So Jake is a 12-year-old boy who stutters. He's left-handed. Upon formal audiological assessment, Jake responds more rapidly to verbal and auditory stimuli in his left ear than in his right ear. His clinician determines that he displays left ear advantage. Upon examination of an electrocephalogram and EEG, clinicians determine that his brain waves shows suppression of the alpha waves in his left hemisphere.
Sorry.
Here are just a couple of clinical methods. So we have an ear advantage, and then we have an auditory and verbal stimuli, as well as study of handedness, an electroencephalogram, static brain imaging, which consists of an MRI or CT scan, and then functional brain imaging, which is a fMRI. Some research on cerebral dominance. So, or in 1927, researched adult left-handed stutterers that had been retaught to write with their right hand. The study found that their stuttering disappeared a few months after beginning to utilize right hand equally to left. The conclusion from the study was the research led to Orm's formulation of the cerebral dominance theory in stuttering. Here are a few more. Broadbent, 1956, performed dichotic listening tasks. He presented different stimuli to each ear, and that he found stimuli in each ear generated a different response and different speed of response. Kimura, in 1967, studied clients with epileptogenic lesions on their brain. He introduced dichotic verbal stimuli, and he found that verbal stimuli are processed more rapidly when introduced to the ear that is contralateral to the speech processing hemisphere. Warren Haynes in 1980 utilized EEG. They found asymmetry of alpha waves produced on EEG, and it showed suppression in the right hemisphere of adults who stutter. Fitch and Batson in 1989 utilized EEG to analyze the alpha wave patterns of 12 fluent male participants and 12 disfluent male participants. The 12 fluent males' EEG results did not show any hemispheric asymmetry. The 12 disfluent males showed a small but clinically significant hemispheric asymmetry on their EEG results. And here are references. Perfect.